Oh, hey, what's up, everybody? We're going to continue our journey through reciprocal functions. We're going to do this right about now. Now that we've discovered what a reciprocal is and what horizontal and vertical asymptotes are, what we're going to do next is whenever we are presented with a function, and we're going to stick with linear and parabola functions for this. So, okay, we're just doing two different types of functions. But what we are asked to do is to sketch the reciprocal of this function on top of its original graph. Similar to what you did in 12a recently, except in Ms. Johnson's class, what you would do is you would take a y value and get the square root of that y value. For us, what we are going to do is similar, but we're going to get the reciprocal instead of the square root. So how you can start here is you can just pick any random point on this line. Doesn't matter where you start. I'll start right here. If you take a look at this point right here, I'm not concerned that the x value is a 0. I'm not looking at x values. I'm looking at the y value. And the y value here is positive 3. So if we take a look at what is the reciprocal of positive 3, it's 1 over 3. Or if you round it off to decimal places, it's 0.33. So we just go in a vertical direction down to what we think is approximately 0.33, 1/3. So notice when I made my new point that corresponds to that original y-intercept point, what I did was I just reciprocaled the y value and moved vertically to that new y value. I don't consider the x values, and I don't move left or right. I just move up or down. So that's one point on our new graph. We can find some more. Like, for example, if we choose this point right here, this is a positive 2 on the y value, on the y-axis. Reciprocal of 2 is 1 over 2, or a half. So I just moved down to what I consider to be 1/2. Again, it's just an approximation, but I did not move left or right. I just moved up or down to the reciprocal of that y value, which is 1/2. We discussed points, number values, where the reciprocal was the same as its original value. The numbers 1 and -1, the reciprocals of those numbers are the same. So for in this case here, okay, we have a y value of 1 on this point right here. Well, we don't need to move that point because the reciprocal of that y value of 1 is still 1, so it's still in the same place. And likewise, down here at -1, the reciprocal of -1 is itself. We have special terminology for those 2 points there. They're called invariant points, and you're going to see that coming up very shortly. But let's just stick with fleshing out this graph. So we can take a look at some other things here. For example, why don't we take a look at this point right here? You see a -5 there, but we're not concerned about -5. We're looking at the y coordinate only, and we could approximate right there that that's probably 0.5 or 1/2. Well, if you reciprocal 1/2 or 0.5, you go 1 divided by 0.5, you're going to get a positive 2. So this is going to move up here to positive 2. And similarly, okay, let's take a look at, say, this point right here. Again, we're just picking points at random, no particular order. But this point right here at -2, right, not the -10, that's the x value. The y value is -2, so if I reciprocal -2, I get -1 over 2, or -0.5, which is approximately there. And then similarly, I could look at this point right here, which is a y value of -0.5, like we have -1, -2, and so on. So the y value at this point right here is approximately -0.5. The reciprocal of that is -2. Not moving left or right, just moving up or down. Now, there's one other number we said that does not have a reciprocal at all. That is the number 0. You cannot get the reciprocal of 0. 1 divided by 0 is undefined. So notice that this point right here has a y value of 0. The reciprocal is undefined. So what we're going to do is we're going to write in a vertical asymptote because the graph cannot cross this particular vertical line because the function is undefined there. And then if we start looking at the points that we do have, we can start drawing a curve, and notice that the graph just gets closer and closer to that asymptote as I connect all these points right here. So I have a vertical asymptote at x is equal to -6. With these questions, okay, you're also going to get a horizontal asymptote, which really is just the x-axis. You can notice here that the graph is not crossing that horizontal line. That's a horizontal asymptote. Let me write this in a little better here. Horizontal asymptote of y is equal to 0. You're going to see that horizontal asymptote a lot, but the vertical asymptotes are going to change. And then these points where the original graph crosses the new graph, they'll always have y coordinates of 1 and -1. And we call those invariant points. So we know we have a y value of 1, and at this invariant point, we know we have a y value of -1. There's a little more to all this, but we're going to just stick with sketching functions given original functions. In this next video, we're going to do the same thing, except you're going to get an example with a parabola.